This week, we'll finish the discussion about classes and objects. And I would like to start our discussion first with the idea about data types. So this is not really something new. We are just revisiting this idea one more time. This might be the final time we're going to see the idea about data types. It's really important for you to understand what it is. And then later for all your other subsequent courses in the second year, third year, the idea about data type is really important. Okay. Let me review this definition here, and then I'll go for some illustration quickly. So a data type is basically a set of related runtime values, or values that are actually allowed to be assigned to the declared variable. Let's now do some quick illustration, and then we'll go over the slides. Okay, so we talk about basically data types, and let's remind ourselves what's the syntax for declaring a variable. So we talk about variable declaration, which has two parts basically. Okay, you can see we have the type over here. So this will be the type. I'll give you some example in just a moment. So we got type, and also we got the name of the variable. Okay, so this will be the name of the variable. Okay, let's see one example right away. For example, we might say integer and then x. And we might say something like maybe a string, maybe s, and just one more. And as you have learned in the Java tutorial videos, we have a class called member. We can also say member. Member, and let's say maybe Alan. Right, so these are all the valid declarations for Java, right? So you start with the type, and then followed by the name of the variable. All right, and we can categorize data types into two categories basically. Okay, so this particular category over here, let's start with this. So example like an integer over here. So this is so-called primitive type. And other primitive types include integer, and also we got Boolean, and also we got double, and of course float as well, and also character. And the characteristic features for primitive types in Java is the names will be all lower cases. You can see there's no capital letter. And what about the other category? And the other category is over here. It's called reference type over here. And the characteristic feature for reference type is typically it should be capitalized for their names. So this is called reference type. And for reference type, you have two possible sources. Okay, and source number one over here, you can see, for example like a string. And notice that string is a reference type. So for reference type like a string, they actually come from Java library, meaning that these classes are already defined for you to use directly. You don't really need to develop from scratch, and string is just one of them. And the scanner class that we have been using for your console application is just another example for the reference type. That's from the Java API library. And for the classes you are forbidden to use for your labs and also programming tests so far, like an array list or arrays or even system class. So these are all example for Java library classes for which if you use it as a type, it's going to be considered as reference type. All right. Another source for reference type is over here. Another one is which is the most important that we want to focus on. We want to emphasize. So class like a member, which you did in your Java tutorial video, right? From week number 6 to week number 8. So member class is something we created. So this will be from customized Java projects on your own. All right, so these are the two possible sources. It would be basically, so you can see primitive type. It's very easy to enumerate. It simply just be integer, all the elementary programming types that we spoke about. You can refer to the very first week's lecture. And then for reference type over here, it can either be from Java library or it could be from your own projects. Okay, and let's now talk about the consequences, right? If you remember, let's recall again the definition. A type, either primitive or reference type, it will denote a set of related runtime values. So here, runtime value is really important. So there are two kinds of runtime values depending on whether you're talking about primitive or reference type. Let's see over here. When we talk about variables over here, the way to visualize them is to draw a box, right, for like a placeholder. Let's say this. In the case of primitive type, variable x, so I can visualize like that, right? You can see x over here, and then whatever we can store over here, allowable value store at runtime. Depends on the type. Depends on the declared type. Okay, for example, in this case, I declare x to be integer. So that means I can only store integer inside this particular box. For example, 23 and also maybe 6. On the other hand, 23.4 cannot be stored into an integer variable unless you do some cast, right? That's something we said in the week number 1. And for sure, you cannot simply store false, like a Boolean literal, into this x. You can also not store maybe a character or a string into an integer variable. So it's really important to see the allowable. So this is really the keyword, allowable value stored at the runtime. So once you declare the type, it really tells you the set of allowable values you can store in this particular variable, right? That's for primitive type. And for reference type, it's very similar, except that the value you store inside the box will not be a simple value anymore. It will be some address, which will indirectly refer to somewhere in the memory, right? So let's visualize it quickly. And when we talk about reference type, let me now use the same color here. So when we talk about, for example, either S or Alan over here, so these are the reference type variable. So now if I put it, let's say over here, and let me just say, for example, let's say Alan, okay, just for example. If I put Alan over here, so now for reference type, what would be the allowable value? Okay, it will be similar idea, but I want to distinguish over here from the case for primitive value. It will be the allowable address value, right? Address here is very important. Allowable address value of a class. You know what? Let me just be more precise. Allowable address value of an object's instantiated from the declared type. Let's see one example right away. Okay, let me just write it properly over here. So now you can see here, since I declare Alan to be of type member, so that means the allowable address value I can store inside Alan placeholder will be an object instantiated from the declared type, which is member, which means I can only store member object address into this particular placeholder, right? However, there's one small detail here to add. The way we visualize primitive type, no question, we simply just draw a box. However, the way we draw reference type variable, you can put it like that. You can refer to our detail, more like a physical oriented tracing before. You can definitely store the address over here. However, it would be more intuitive if you simply say Alan storing the address of some objects. You will simply point to that particular box that's visualized as the object, right? But the same idea. So these two, either you can put an address over here, or you can simply say Alan pointing to another object. So these two notations are completely equivalent, but this is more recommended when you try to trace objects creation and manipulation. All right, guys, that's about a final reminder, really the ultimate reminder about data types and also variable declaration, right? Recap. It can either be primitive type or it can be reference type, in which case it can be either from Java library or it can be from your customized Java projects. In the case of primitive type, in that case, the value that's allowed to be stored depends on the type, for example, integer, right? And in the case of, let's say, reference type, the allowable address value, so that will be instantiated from the declared type, right? That's really important to see. Whatever address you can store here depends on the declared type over here. For example, Alan is declared to be member. All right, it's really important for you to get this straight. All right. Let me go back to the slides, and then the rest of the slide is has been already set. Okay, so we got primitive types. You can see all the numeration over here. We spoke about it in the elementary programming lecture, and also we got reference type. So these are complex type in the sense that we don't really store just a single integer or maybe or a single string. Remember, in a template like a class, you can declare as many attributes as you like. So that's more like a complex type. And when you instantiate from a particular template, that object will share all the objects from that particular template will share the same structure. Right? That's why it's called complex type with attributes and methods. All right, and then string is definitely a reference type because it's capitalized, right? It's from Java library. And also we got person, we got member, we got point, we got scanner, and etc. Right? So the category of reference type is much larger in Java or in any other object-oriented programming language, right? Because for the primitive type, you can only just numerate like this, right? And no more, right? Reference type is definitely much larger category. All right, the next slide is really about what about the value, the default value you can store in the variable, right? So for example, if I only declare, integer x without initializing it, so that means x is going to be assigned the default value automatically. And similarly, if I only declare s and also Alan over here without initializing them explicitly, with some new object expression, in that case, they will be assigned to some default value. So the default value for primitive type versus reference type would be different. Let's take a look. So here we got primitive type. Integer would be 0, easy, and double would be 0.0, and Boolean will be false, right? The rationale for why the Boolean type, the Boolean data type should be false is kind of beyond the scope for this course. However, if you are interested in knowing, please ask me this question in the Q&A, and I can maybe spare some time to explain to you why the default value for Boolean should be false. But that's something you should know, right? And then for reference type, either for member, for string, for point, for scanner, it will be all the same because it's simply about storing some address, right? And what about the what would be the default value for an address value? Well, it would simply just be null, all right, just null for string, null for person, and null for point, and etc. And also for scanner. And you can use a primitive variable that is initialized. For example, I might say integer x over here, and then I can say integer maybe y is simply assigned to x. I can use it right away, right? Because for primitive variable, you cannot invoke any methods. You can only do some simple manipulation. For example, if you just cannot say, let me say this. What would be invalid to say? For example, if you say x over here, if I say x dot maybe some method over here, it will definitely be invalid, right? For primitive type, you definitely cannot call any methods. Methods are only for applicable object types, only for objects. Okay. On the other hand, you can say s dot equals. That'll be one example. And also you can say Alan dot maybe set trainer. Of course, given that they have been initialized properly, right? All right, let's go back here. And then make sure the default value is really what you want, right? So if you really want to say this without initializing x, which means it's going to be 0. And then if you try to say integer y is assigned to x, in this case you should really know x being 0 is really what you want, right? Another example I can refer you to, you can refer back to the common errors for the loops and array. If you go back there and remember, one of the errors is about if I want to use a Boolean variable to really say while the user wants to continue, I should really keep prompting the user for another string. Right? Remember that example. You can refer back to the lecture slides in the previous week. And for that one there, I didn't really initialize the Boolean variable, meaning that it's going to be false. However, false may not be what I intended to have. So that will be another example. So for primitive variable, make sure you initialize it, or if you don't initialize it, make sure the default value is really what you want. That's the principle. And for reference variable, here you gotta be very careful. And in the tutorial videos for week number 8, we already talked about if you try to invoke some methods on a null slot in the array, like a null address, it will give you null pointer exception, right? So for example, if you simply say this, if I say Alan, simply like that, so that means at the moment, Alan is going to be just pointing to null, right? And then if I just call a method right away to say Alan dot maybe set trainer, for example, in that case, it's going to be a null pointer exception for sure, right? So let me write it down very quickly. It's a really important point to see. Null pointer exception is definitely the most common logical error you can encounter when you are programming OO. Let's say this. If I simply say Alan, simply say this, it's not initialized, and then so that means Alan will be pointing to null, right? And then if I try to say Alan dot maybe set trainer right away. If I do that, and then of course pass some trainer objects over here, so now this is going to be null pointer exception, right? Null pointer exception. It's very important to be aware. So always initialize your reference type objects, always. Yep. Okay, so that's about the Java data types principle I'd like to revisit, and then hopefully you can study that, and got any questions, ask me during the office hour or in the review session.